Hi everyone, today I'm going to take you through some tips on how to design figures for our BMS 3031 week 7-8 activity. So let's imagine you've picked a paper that's been published by your lab head. I've chosen one of my own here, and you've read through it and you found an experiment or a result that you think is really important to their research. And you now want to turn that into a figure which explains how it was performed and what the results were. So in this case I've chosen a figure which shows that SOI, the male sex determining region on the Y chromosome, transcriptionally regulates two key dopaminergic enzymes, tyrosine hydroxylase and monoamine oxidase A. And that's a key finding in one of my papers. And so to illustrate that in a diagram, it's going to take a few steps. And so I'm going to go through that shortly. So what the first thing you should do is firstly look at the figure itself and see whether there's any hints there of how it was performed. So in the figure legend you can see gives us the results straight up, so the clear result, upregulation of TH and MAOA levels by SOI. So that's the result. And how was it done? Transient transfection of NT2N cells with SOI flag and GFP in a 3:1 ratio were fact sorted to isolate positively transfected cells. QRT-PCR showed TH and MAOA mRNA levels are significantly elevated when cells are transfected with SOI. So there you go. So you've got some clues there, and you can see here that the NT2N cells, some of them are SOI positive, and a subset of those are GFP positive. So they're obviously the ones that we're trying to collect, the ones we're sure that SOI is expressed in. So the next step you should do is to look at the methods. So if we go to the methods here, and I've just pulled out all the methods that relate to this figure, obviously you'll see that there's a lot going on. And so what you need to do is you need to basically synthesize this into a figure, and the way you do that is by highlighting some of the key points. So I've already started. So NT2N cells, SOI transfection vector, retinoic acid treated NT2N cells for 7 days. So you want to try and pull out the important parts. And once you've got all those important parts, you need to start sketching out how they fit together. And that's what I'll show you in the next video.